Good evening, folks. Well, in this video I'm going to have a look at scientific models, and I'm going to use a couple of examples to try and explain my take on what a scientific model is. Okay? Now, there's plenty of people out there who want to big note themselves, who might come to my channel and try to tell me that this is wrong, that's wrong, take down my video. Well, that's not going to happen. Okay, I'm not taking down my video. This is my take on it. If you've got a different view of it, go make your own video about scientific models. Okay, this is what I think. Okay, now the reason that I've decided to do this is because I've come across quite a few videos lately, and even met some people online who completely misunderstand what a scientific model is. So let's have a look at what they say. Up here I've made a bit of a list. That's misunderstandings. First of all, they talk about the truth. So they think that a scientific model means that this is the truth about the way something happens. In other words, this is it, locked in stone. Everybody should believe it. Everybody should think that this is what happens. Okay, this is what they think that a scientific model is. And some of them even think that a scientific model means a smaller version of something that's huge. Okay, so like a model car is a representation of a small representation of a very large car to some sort of scale. So they think that that's a model. That's another misunderstanding. They think that lies can be associated with models. In other words, if a model can be truth or it can be a lie. So they even use that word, and it's actually what's prompted me to do this, because there is a fool on the internet, actually an obnoxious fool on the internet, who berated a teacher, conspiracy cats, because the teacher had the temerity to describe Newton's law of universal gravitation. Okay, so he clearly doesn't know what a scientific model is, let alone know anything about the subject of gravitation. Alright, let's have a look at some other misunderstandings. There's manipulate data. So they think that data is manipulated, and for some reason or other the data is manipulated in order to create a model. Nothing could be further from the truth. Okay, the model isn't there about trying to convince anybody that this is what happens, this is the fact, this is the truth. The model is there to try and get the data together and explain what's happening, explain the data, explain the observations. Okay, it has nothing to do with needing to manipulate the data. There's no point in doing that. They think that models are fiction. Well, they're not fiction. That is a useless word to use when describing a model. A model is just an explanation of how things work. An explanation that can be used in order to make predictions and things like that. So this idea that it could be fiction, that it's wrong, is ridiculous. It's a useless adjective for it. That there are conspiracies, that the model revolves around some conspiracy to mislead people. Models aren't there to convince you, and they're not there to mislead you. So convincing and misleading are irrelevant to what models are. Let's have a look at how they come about. Might give you a better idea. First of all, we have the observations. So an observation is made, or a series of observations are made, and the people making that observation want to examine it further. They want to investigate this observation and find out what's happening, what do they think is happening, and how can they use that information to harness some sort of model that will allow them to make use of it. Okay. All right. So they form a hypothesis. So they look at that data and that observation and say, well, I think maybe this is happening or that's happening. So come up with a hypothesis for why they think that something's happening. All right. That's usually based on on a pretty good guess, and often underpinned by science. In other words, the science that came before that. So once they've got that, then it's now time for experimentation and data collection. So this is collecting all the data as accurately as possible and doing experiments, formulate experiments that try to explain the hypothesis. Okay, so it's just gathering this data, doing experiments. There's no need to falsify this if you are creating a model. People don't falsify experiments in order to create a model. They might falsify experiments to fool somebody about a result. But they're not going to falsify data in order to falsify a model. That doesn't make any kind of sense. So once they've got the data collection, they're then going to make some conclusions about it. So let's have a look at Model X. So in Model X, let's have a look at the different parts of it. Forming a coherent theory. So that's an important part of the model. Creating a theory that explains this hypothesis. Okay, so that's a very important part of it. And coherent, meaning that it explains many different parts of this observation all at the same time. Okay, check the data with the observation, see if that matches. Make accurate predictions. Does the model allow you to make predictions, accurate predictions? Is that model falsified? So in this case, not yet falsified. So if it's not yet falsified, that means there's nobody out there who's come up with any good reason to say this model is not working, or this model is no longer coherent, or this model is incomplete, or this model is entirely useless. No one's done that. So, used in real life problems. That's why you have a model, so that you can use it, so that you can explain what happens, and then you can use it. You can use it to make predictions, and often you build a model so that you can use it in real life situations. This might be even in academia, or in business, or in manufacturing, you name it. You might make a model that'd be useful for something. Okay. And a model like this, that satisfied all of these, we would call that mostly complete. And I say mostly because every model can be tidied up. Every model can be fixed up at the edges. You know, things aren't quite there yet. Not that anything there is wrong, it's just that they haven't gone to the extent of explaining everything. Okay, there might be some little bits at the edges that are not explained properly. Okay, but it's mostly complete. Now, for instance, an example of that would be Einstein's gravity model. This hasn't been falsified by anybody yet. Plenty of experiments have been done that verify it. It's an extremely cohesive theory that covers a lot of ground. The GR covers all sorts of different observations, all at the same time and accurately. Yes, we can use it to make predictions as well. And used in real life situations. For instance, clocks on satellites would be an example. Okay, let's have a look at this Model Y. Model Y is Newton's gravitational model. Does it form a coherent theory? You bet it does. Universal gravitation, we're looking at satellites, planets, stars, all of those things explained by Newton's gravitational model. Still used today. In everyday life, we talk about F equals ma, that's force is mass by acceleration. This is used in building construction. All sorts of areas of life are using Newton's laws. Does it make accurate predictions? Of course it does. If you fire a missile, you want to hit a target, you're going to be relying on gravity. You're going to be relying on Newton's model. Okay? They don't dig out Einstein's model and work that out. Newton's model is what they use. Newton's model is what's used to put a satellite in orbit. Newton and Kepler. Those are the models, work together. Does it explain cause and effect? Not completely. That's why I put the cross there. Because Newton himself said he didn't understand how gravity worked. He just knew what it did. Okay? He didn't understand why it worked. But he did understand all the things that gravity did for him. He built this model in order to be able to use all of that information he gained about gravity to make really, really accurate predictions. Predictions that we still use today, as I said before. Has it been falsified? No. Not even Einstein did any falsification of Newton's model. Einstein just added to it. Newton did say that his model was incomplete. That's why I put a cross right there. Okay? Because it doesn't explain the cause and effect. We only get one side of that equation. Okay? We can see what happens, but we don't know why, from Newton's point of view. That's what Newton thought at the time. So this is where Einstein came in and thought he would pick up the pieces and say, let's run with it and work out the why. And that's what he did. So he put his model of gravitation together. That doesn't mean that Newton's model is no good or superseded. It's a model. That's all it is. It's a method of describing something. Just like I'm describing this to you. Someone else might have a different way of describing this to you. Is it used in real life problems? I've already told you that. Of course it is. In fact, it's used more than Einstein's model is. This is used all the time. Architects, engineers, space travelers, explorers. You name it. Anything that you do, you have to drop something. Newton's law will be used. Newton's third law, used all the time. That's how we know how hard to make the concrete. Because that's calculated. Gravity is used in the calculation to decide how much aggregate to put in the concrete, how strong to make the concrete, how many kilopascals the concrete's got to be able to hold. That means how much force over a given area it's got to be able to hold. What's force over a given area? What's force? Force is the mass times the gravitational acceleration. So force over a given area is the mass times the gravitational acceleration over a given area. This isn't hard. I don't know why these flat earth people are struggling with this, or these conspiracy theorists. Okay. Both of these are used successfully. So a model isn't about saying, well, this is the truth, so therefore we'll discount everything else. This isn't a religion where you say, I buy into this particular set of tenets and therefore I have to reject the other tenets. This is just a model that says, look, I think that this is a really good explanation for what's happening. It is no more than that. I think, Newton says, I think this is a really good way to explain what's happening. You can use either. You can use both. It's okay. And if you've got another one, you can use a third. That's how models are. You use one that suits your environment and your purpose. It isn't something that you say, this is the truth, and everybody better believe it. Now, why do teachers teach both of them? Why does this teacher, Conspiracy Cats, teach Newton's one? Well, he's probably teaching at that level, maybe GCSE or something like that, where the curriculum has Newton's gravitational model on it. Maybe it's not going to go into Einstein's model, because that might be done at A levels or at university. I teach people about Einstein's gravitational model, and quite often most of the students that come to me don't know anything about it at all, or maybe just a small amount. So it's clear they're not teaching it at school. So they're leaving this to university graduates, undergraduates. That could be an explanation for it. This here, something that's probably going to be taught in high school. And why would you do that? Because not everybody is going to go to university. So, but the people who aren't going to university still need to be able to understand this, because they use that in real life all the time. Maybe they want to join the police force. and do crash analysis. Well, if they do crash analysis, they're going to have to understand about conservation of momentum, aren't they? Where are they going to learn that? Well, they could learn it in school, thanks to conspiracy cats. Maybe they have to work out how many kilopascals the concrete's got to hold. Where are they going to learn that? People don't go to university necessarily to learn that trick. You learn it in school. So it's necessary for him to teach those students Newton's laws. They apply to everyday life. This model is extremely useful in everyday life. Einstein's model is not. But maybe if you want to learn more about physics later on, at a higher level, and you want to take models of gravity even further, then yes, you're going to learn about Einstein's model. None of them are anything to do with truth. They're just a means of explaining something. So the flat earth people who say gravity doesn't exist, that is ridiculous. I doubt I've heard anything more stupid than, I have to admit I have actually heard something more stupid, that idiot berating the teacher. That is about as stupid as I've ever heard anything in my life. And trust me, I have heard some stupid. Now, let me just reiterate. The model is not about saying this is the fact, this is the truth. You better believe this, you better not believe that. Nothing to do with it. It's totally irrelevant. The model is just simply saying this is a good explanation for the observations that we see. Right. Use the models, which includes equations, standard operating procedures, all those sort of things that you can put together in this model so that it works for your benefit, for the things that you want it to do. If the other one does a better job at certain aspects of it, pick that one up. You can use both. You can use this model for these things, that model for something else. You can put them both together. They don't supersede each other. There's no such thing. Okay. I don't mean to be cranky, but sometimes when I think back to that video that I watched, that fool berate conspiracy cats, it makes me quite angry, because I know teachers are fantastic. Teachers should be on a really, really high pedestal in our society. They're not given anything like the respect that they deserve. It's teachers who have to put up with people like this sleeping warrior dude. And they do a damn good job. So you keep it up, conspiracy cats. Alright, I think I've said enough. If you like my videos and you want to hear more, then you know the drill. Press that like button or dislike button, whatever floats your boat. But you don't subscribe, and then that little bell means that you'll probably know when I'm doing them again. Okay? Alright. I'll see you again next time.